I'll show you how I built this circle cutting jig that works with both the bandsaw and the router table. You may have seen a previous video that I did that compared this jig to one that I purchased that works with a trim router. And in this video, I'll show you how to build this circle cutting jig. So let's dive in. I started by drawing a sketch of the basic dimensions of the base plate and the top plate. You can freeze the video and grab these dimensions. Just beware your router table and bandsaw might have slightly different dimensions than mine. To make the base plate, I start by cutting a piece of 3/4 inch plywood to the dimensions of 11 7/8 by 15 inches. And I also cut a 1.5 inch wide strip that'll be used for the stop block. I then use a 3/4 inch straight bit on the router table to cut a groove for the T-track with a depth of about 3/8 of an inch. And when cutting it, I stop about 1 inch short of going all the way through. Then I reduce the depth of the cut and move the fence over 1/2 inch so that I can cut a groove for the stick-on measuring tape, and it's only about a 1/16 inch deep. Just doing a quick test fit of the T-track and the stick-on measuring tape, and things are looking good. The next step is to drill 1/4 inch holes, which will be used for the bandsaw miter slot expansion hold downs. Before I attach the stop block to the base plate, I need to get the base plate aligned on the router table. So the first thing is to install the 1/2 inch router bit that I'll use with this jig. I want the jig to work with either a 1/2 inch bit or a 1/4 inch bit, but the 1/2 inch will determine the limiting position of the jig. Then, just to make sure it's square with the table and clamp it in place, I'm just attaching it with screws, not glue, so that if I ever change my router table or if I want to use this jig on some other machine, then I can just move the stop block. The side rails are 1/2 inch plywood with 5/16 holes drilled to hold them down to the router's table side T-tracks. So just going to do a quick test fit, and everything's looking good so far. With the base plate done, it's time to move on to the top plate. I bought this piece of melamine that's pre-cut, intended to be used as a shelving solution. It's 11 7/8 inches wide by 24 inches long. I like melamine for the top plate since it's a sliding surface to rotate the workpiece on, and I just think it's a good surface for that. Using my sketched plans as a reference, I mark where all 4 holes are to be drilled. I first drilled the 3 holes that are the 2 inch diameter and then drilled the 3 inch hole. Once the holes are drilled, then I cut the 3 inch wide slot on the bandsaw. Now I attach the top plate to the bottom plate, just using screws and making sure that the heads of the screws are sunk below the bottom surface of the bottom plate. Using a crosscut sled on my table saw, I cut the top plate length to match the bottom plate. I waited until the top plate and bottom plate were both attached before cutting the top plate to length, so I didn't want to risk breaking the narrow ridge on the top plate. Using a round over bit on the router, I knocked down all the sharp edges and also clean up where the hole saw chipped the surface of the melamine a bit. I'm using some epoxy to attach the T-track. Since the screws have to be so short because of the thinness of the bottom plate, they probably wouldn't have enough strength to strongly secure the T-track by themselves. I'm going to cut the cookies out of the strip that I cut out of the top plate center slot. Do you call them cookies or biscuits? I don't know. I guess it depends on what country you're from, but I'm in the US, so I'll call it cookies. The thickness of the cookie needs to be about 5/8 inch, so I resaw it on the bandsaw to slice off a little more than 1/8 of an inch. I first drill a 1/2 inch diameter hole where the aluminum bushing will go, and then using a hole saw, I cut the large 3-inch diameter cookie. And repeat the same for the small 2-inch diameter cookie. Having two different size cookies kind of complicates the design, but the reason for the two cookies instead of just one is that the smaller one is needed for smaller circles and the larger one provides a bigger surface for the double-sided tape for larger circles. I'm going to use these alignment lines when attaching the cookies to the workpieces, so I just extend them around the sides and mark them in ink. The final step to finish the cookies is to glue in the aluminum inserts with epoxy. The purpose of these inserts is just to avoid wear over time. If I just rotated the raw wood around the pivot screw, I guess I'm concerned it would wear too much over time. The aluminum inserts have a 1/4 inch inside diameter and a 1/2 inch outside diameter, and they're a 1/2 inch long. You could probably buy them at your local hardware store. I got these online. They're less than $1 each. The hardware for the rotating pin is a 1/4 inch T-track bolt and nut and this measurement pointer. I cut the pointer from a piece of sheet metal with a metal blade on my jigsaw and then painted it black. Not my best looking work, but it's functional. It's time to cut the first circle with the jig and test it out using a piece of scrap wood. I mark where I want the center of the circle and attach the cookie using double-sided tape. Then I attach the jig to the bandsaw table, making use of the miter slot expansion clamps, and then lock down the rotating pin. Making the first cut with the bandsaw works great and goes pretty smoothly. The bandsaw gives a pretty clean cut, but as expected from a bandsaw, it isn't really a completely polished cut. Then moving over to the router table to clean up the cut edge. Right away, this doesn't look right. The router table is just supposed to do a small shaving off to clean up the cut, but this is cutting off way too much, so I just stop it. I'm thinking all my measurements are based on a 1/4 inch bit, and although I thought a 1/2 inch bit would also work fine, but it's looking questionable. So I put on a 1/4 inch bit and continue the cut with really much better results. Good thing for practice pieces on scrap wood. So I go back and start over again with a new practice piece, following the same procedure. First to do the rough cut on the bandsaw, and then I clean up the edge on the router table. And this time I'm really getting the result that I expected. The last step in building the jig is to attach the stick-on measuring tape. By making a pencil mark where the pointer was for that last cut, and then measuring the final dimension of the workpiece from that cut, then I know where to stick on the measuring tape. The workpiece ends up being 6 7/8 inch diameter, so 3 7/16 radius, and that's where the measuring tape needs to line up to the pencil mark. And the jig is finished. And here's a quick example on how the jig is used. I set the jig pivot pin to the radius of the desired cut, which is 4.5 inches. Then set the workpiece on the jig and make the cut on the bandsaw by just pivoting the workpiece in a circle. The result is a pretty clean cut and a perfect circle, and depending on what you wanted to use this for, it might be good enough, no need to take it to the router table. However, any bandsaw cut is always a little rough, so to make an even cleaner cut, I take it over to the router table. This is just a really shallow pass for the purpose of making a clean cut, and it also dials in the exact diameter as set on the measuring tape on the jig. And just to confirm that the final dimension is exactly 9 inches as desired, and it's a really clean cut. Thanks so much for watching, and if you think I've earned it, it'd be great if you hit that thumbs up like button and consider subscribing.